Good afternoon. This is the last talk for the day, so I still will try to make it as least boring as possible, I promise. Yeah, but first to myself, I'm Sebastian, and I'm the chapter lead at the company kartenmacherei for the Backend chapter for all the Backend developers, apprentices. I'm responsible, and a bit more to the kartenmacherei. We are doing cards, as the name is saying, invitation cards for all emotional events. So like birth announcement, weddings, save the date. We are today both 7 years old. We are already 127 people in the company, spread over 3 locations, and we have 6 different stores online right now. And on our platforms, you have the opportunity to build your own design, to configure your own design in a way of several million different versions and variants. Short disclaimer before we go more into the details. All of the stuff I'm talking about is personal experience. So this is what I want to show you is all based on the time being and on the how we build it and how we solve the problem. We know there are other ways to solve it. If you have a different opinion, let's talk about it afterwards, and please approach me afterwards directly, and let's talk about it, because one of our major key points is we want to learn. But now, short about the agenda. We have first, I want to show you our project architecture and how it's set up to give you a better understanding why we need actually smoke tests and why we build it into the system. Then I want to get us all on the same page and what are the different types of tests we have there. Then we go a bit more into detail about smoke testing. I will show you a few things, how we do this, and want to show you this in code as well. And last but not least, I want to show you how we deploy our code, how we deploy the architecture looks like, and how the smoke testing plays into the game there. But first, let's go to the project architecture and let's talk about it, what we have there. And we started with a big monolithic system, which was extremely slow and extremely complex. So we said we have to change there something. And there's a nice quote from my colleague Sebastian about one of our biggest files. The complexity is that big, and he tried it even to name it. That's the name we came up with. I think 4 or 5 platforms didn't even have a name for these numbers, so it's far too huge. So still, our website had loading times, time to first byte of 2.5 seconds for a general product detail page. So we said, okay, come on, we have to change there something. We have to get that sorted, and we have to get below a certain level. So we talked to our bosses and we said, okay, come on, let's do this page. That's how it should look afterwards, after we are done with it. And let's focus only on category pages and product detail pages with these beautiful tiles there, and don't touch the legacy system at all. Or as not in only in the only in the places where it's really necessary. So we came up with the idea of putting up something like that. So we have there a new system which is standing between the legacy system and the web server. So the request we send to the system is going to the new system first. If that can't handle it, we hand it through. So that was our idea. Out of this idea is Fury born. Fury is not just our project name, but it's a horse from a 1950s TV series from the US. It's called Fury as well. And this TV series is about an orphan boy which owns a black horse, which is really, really fast and really, really reliable. So we said, okay, that's what we want as well. So let's call it Fury. And Fury has 2 main components. One of it is the front-end component. The front-end component is nothing else doing than using an Elasticsearch and a key value store, providing everything to the front end. So there is no database involved anymore, and no other components there. But somehow the data needs to get into the system, so the next step is we have a backend component which is preparing the data for us, and that's what I want to show you next, how the data gets into the system. We call that collect and export. We first collect the information from our legacy database. Then we take the data, play a bit around, render some HTML, and put it into our key value store and some data into the Elasticsearch for our customers on the category page. And one thing we do more, and that's where we still really had to touch the legacy system, the pages which were still shipped by the legacy system should look like the new pages as well. So we said we don't want to do the whole HTML twice, like once in the old system, because that was one of the pain points where our team said, okay, we just don't want to touch the old system anymore. But we said, okay, we just tweak it a bit and we export the header and footer into an own dedicated key value store. And we amended just the HTML of the legacy system in this way that it just calls the header and footer from the key value store and sorted. Problem solved. So that was pretty much the only thing we had to do in the legacy code, in the legacy system, to get this connection sorted. Now a request is coming into the system. So as we said before, the request is going first to the new system, and it's going directly from our web server to the application. And the application looks into the key value store first, has a look if we can handle this page, if we have for this dedicated URL some content. We take the content from the system. We might have another look if the customer provided some get parameters like different color, different format for a category page. Then we have a look in the Elasticsearch as well. And what we read all the time as well is like from the session storage, but we only get basic information from the legacy sessions storage, like is the customer logged in and how many items are in the basket. That's pretty much all we read from the legacy system on request. We put everything together, which is extremely fast, and give it back to the web server, then sort it. But how about the old pages? We call it old pages, the legacy pages, which still have to be shipped, like the cross-selling page or a product DF or the checkout is still on the legacy system. We still go to the new system, to Fury, and ask, oh, Fury, can you handle it? And Fury tells us, no, I can't. So Fury gives us back a 404 page or a 404 header, and then we go from the web server in front of it to the legacy system, and it does the normal trick, so as it does before. But if you want to know more about, there's a dedicated talk I give with Sebastian about how this is solved, how we solve the problems, what problems we face there. Have a look on that one. But now let's go to the types of tests. For the tests, we said, okay, come on, we first had to find a glossary, and we identified four wordings, 4 parts of the glossary, and we put them all into a pyramid. The pyramid is supposed to solve, hopefully all our problems. We know today that it's not solving all the problems, but we get to that later. But we said, okay, the really fundamental base of our pyramids are unit tests. So what are unit tests? I had so many different opinions about unit tests before I started to work with kartenmacherei. But we looked into Wikipedia, we talked with a lot of people, so we said, okay, come on, unit tests, it's saying the name already, but no one thought about it before. It's testing the unit. So to talk in examples, we have these 4 classes, and we want to test class 1. So to test just the unit of class 1, we have to mock everything away. But what we are not doing is mocking their class number 4, because class number 4 is a dependency of class number 2. By mocking class number 2, by definition, class number 4 is gone from our perspective because class 2 is mocked. But testing a unit is not everything, because can you see there what's the problem? The unit is working, yes, you can use the toilet, yes. But can 2 people use the toilet? No. But there's even a better case like that. Maybe you know it already. Go on, who built that? It's just not working. So we said, okay, come on, we need something more. We need integration tests. So at integration tests go the next level, but not too far. So we said, okay, but to stay with this example, we said, okay, come on, this time we want to test the integration between class 1 and class 2, so that the integration of these 2 classes are working. So therefore, we need to mock away class 3 and 4, and it's not just classes we still mock away, but any dependency, like databases are mocked, file systems are still mocked. So to make sure that we only test these 2 units as an integration. And at some stage we said, okay, now we talk so much about testings, why not test 100%? So that's a famous number. Most of the people told us, nah, that's not possible. But we said, okay, come on, we should at least try as hard as possible to achieve 100% code coverage. And we managed, but not just with unit tests. So we set up the rule, all our units should be tested to as best as possible, but there are units like a factory, which you just can't unit test properly, because by definition, a factory is creating other objects, other instances. So how to test that with a unit? So we decided, okay, factories, that's okay. We have the factories and we get the coverage from the factories via integration tests, and therefore we managed 100% of the code coverage. We still keep it. I haven't had a look in the last week, but I heard there's still, again, some lines of code missing. So we have to force us again to get to the 100%. But it really helps, since we have 100%, we mainly have bugs only in areas like database, like 80% of our bugs which pop up are database issues, like someone introduced a new format for a card we don't know about, or a new way of writing the format name and a different name which we are not supporting yet. So it's more logical issues we have there. But the units itself, not that many bugs anymore. So we still have there just the tests of the integration. For the integration sorted, we still need to test the next level above. And that's what we call acceptance tests. And acceptance tests, to stay with the example, the acceptance test is just mocking nothing and just running the code. Just see what comes out of the code if we really want to test the class 1 again. And here are no mocks anymore. Here are real databases in place, so we can connect to a database. It's a bit more tricky to write acceptance tests because you have to clean up after each test. You have to get your data you just messed around with, you have to get them back into a valid state. So acceptance tests, that's where we are actually not that good either, because they are taking a lot of time, they are taking a lot of effort, of overhead of writing the test, and we can still improve there. And one of our major issues we have there is the integration and the acceptance between frontend and backend, because all of this is written in code, and we don't have a real, bigger suite of tests between frontend and backend. So we are not 100% certain that all the time that the objects we are handing to JavaScript and the markup guys, that the values are still valid. So, and they can handle that. That's the usual area. That's the usual area where we mess the most of it. But yeah, acceptance tests, we said it. So all these 3 layers of tests are done in either development or stage environments. So we have the opportunity to see this before we deploy. So this is usually like even part of the pull requests. We have it set up that it's running, and it tells us, oh yeah, you forgot that, or you messed up the code of your colleague because he deployed something similar at the same time. But the problem is in production. So when we deploy something to the live environment, we still want to make sure that still all our pages are available. Like as you saw before on the example, the Fury front end is shipping just the pages given. So if there is a page, or by any accident the code missed one page of during the collection and preparing the HTML, the old system would ship this page. This is something we didn't want. So this was too dangerous for us, and we said, okay, we have to solve that. So we were getting back to the boards and drawing some fancy stuff, like how can we solve this, how can we test it? And we actually came up with the smoke tests. Again, short disclaimer, smoke tests, there are different ways how you can approach smoke tests, especially if you're just converting from one system to another and then stay with the system. There are different ways which can do this easily, but we said we want to have that on each deployment. So that's why we decided to write the smoke tests ourselves. But first, what are smoke tests? Smoke tests are usually not coming from IT, as a lot of other stuff as well. Smoke tests is actually testing drains and testing pipes, and that's how it actually looks like. So you pretty much close all the holes of a system, you put smoke in it, and there where it comes out, then you know, there's a problem. Adapted to the software, it's pretty much the same. You test a huge amount of lists of URLs and see if everything is working or not. So we defined there a list what our smoke tests should do, that we don't overdo them too much. And we said, okay, come on, our smoke test should be extremely simple, extremely fast, because we want to test a lot. And we want to test additional parameters. So it's not just testing a dedicated GET request, but maybe it makes sense to just add a couple of parameters, GET parameters to your URL, to just see if maybe the feature behind that parameter is actually failing, is actually bypassing your system or opening up issues. We decided that we want to have there a manual list. So it's not a dynamic list. It's not like, oh, we go to we collect our information, put it into a database, and then we run, sorry, not a database, but into our key value store, and we run the information based on the key value data, because then if nothing is in the key value, nothing gets tested, everything is green, nah, not good. So we said we really want to have a manual list. We want to have this list expanded manually, so to make sure, okay, this is a set which stays alive over years. So even if that page might not be existing anymore, but we want to have valid content behind. So how does smoke tests work? We have there a production server, and we have a CI server. Both of them should stay in the same network, or at least close to each other, because then you can test much better the time to first byte as well. And we just send a request from one server to another and get a response, and look on the response on the status code, look on the response on the time to first byte, and see how it works. If it's not working, if the time to first byte gets above, it just failed. It's just telling us, oh, no, that's not working. So what should we validate? We should make sure that the status code is in a defined status code. So not every of the status codes we want to have is 200. But if you want to test a dedicated redirect, you want to see that the redirect is actually a 302 or a 7, or how you defined it. We want to see that the time to first byte is working. We want to see that a body is shipped, so that there is a HTML body produced. And what for us was important to learn, that was actually a learning we had to make first, is that we're actually on the correct server. So because it happened to us that we ended up doing the smoke tests, and the smoke test was failing, and we were, no, but if I open the URL, everything's fine. So yeah, problem was that we actually, the smoke test went to the wrong server. So that's what we double checked there as well. What SmokeTests is not for is doing acceptance tests. There are better libraries. So you don't want to test that a dedicated div is available. It's just a matter of really testing that the page is there. Because for tests like that, then it's where it gets slow, and tests like that should be done, for example, in Selenium. That's pretty much the source code which came out of it. So we have there quite a long list of URLs at the bottom. We use the data provider for from PHP unit, and we then check if the status code is correct, check the time to first byte, and see if the body is available, if there is a body transferred. That took 45 to 50 minutes for each deployment. So that's another no-go. We said, okay, that's not gonna work. And there's another loophole, there's another tiny bug in here. I left it actually. Sebastian, you still see it? So just to have that number here, this is saying we get the time to first byte in milliseconds, and we want to have 100 milliseconds. That's valid. But what we didn't check is what is really coming out here. So we developed it in here, and we are not getting there the value in milliseconds, so it as an integer, but we got it in seconds as a float. So the script would fail if we are staying above 100 seconds. So we had to fix that. So, but still, how do we fix this problem? How do we solve that problem to gain there more speed, and to gain there more speed without burning down our servers? So we said, yeah, let's try concurrency. And concurrency, you might know, that is really tricky in PHP. And to get that sorted in PHP, because we don't have that good threading and not that easily set up. But let's stick with the point. We use their curl library, and the curl library is taking that over. Even if it's tricky to develop and to handle there any issues with multi-curl, but at least it's working. So the idea of concurrent smoke tests is that we send 3 requests in this example at the same time to the dedicated server. And as soon as the first one is responding, we send up the next. And as soon as another one is responding, we send up the next. So we did this on and on and on. There is some stuff which is not good at some stage, so happens, but that's what we want to see. But what we don't want to see is by using the concurrency is actually that. We don't want to burn down our servers. So we said, how can we achieve this? How can we make sure that our server is not going down by our own tests? And so we said, okay, come on, we have to calculate this. This is our how it looks pretty much today. And we defined the best way of, or the highest way of concurrency is quite easy to calculate. It's actually the number of cores of your production server minus 1. And that's it. So that's the easy calculation. Then the graph looks something like that when you run the smoke tests. And as you can see, it's a deployment process, which is continuous delivery. The good part is you don't need to write all that stuff yourself. For this talk, I built last Christmas, over the Christmas days, I built the library for it and made that available under MIT license. So have a look and use the code. And I want to shortly go with you through this code. So in this code is again use PHP unit as the dependency, as the library to go. We still have our application on the other side, and again we use the data provider. To know PHP unit, when you run a test, the test is using the data provider. The data provider gets run before the test starts at all. So it's not like back and forth, but it really looks like this. So the PHP unit starts the data provider does all the requests and handles the responses, prepares the result objects, hands the list of results objects back, and then PHP unit starts one test after another. In code, that looks like this. So it's quite easy. It's fully object-oriented. It's, again, 100% code coverage as well. And to explain it a bit more in detail, so we have first the list of URLs. You can take an array like here, or you get that from a file or database or whatever you want to have there. Put it into an URL collection. Then you create the SmokeTest options where you have information like, where is it here, the body length. The body length is not, just to repeat, is not there for handling and testing the body. It's just there for two purposes. First, to check if there is a body transferred. And second, usually in the first 500 characters, you get the PHP warnings and the exception messages if there is something failing. So to give you a proper debugging output when there's something failing. Then the easy part is you just use a trait, introduce into your test class a trait, and the trait is providing you with all the features you need. For example, that you have a result object, and that result object has all the information, like the body, like time to first byte, all the headers if you need them, and then you can test them. So we put even some assertions, like in the PHP unit style, in there as well, to have assertions like success, and double check the header if you want to dedicatedly check if the correct server is reached. A failing output looks like this. So we have there just 200 and a bit tests. One is failing. And by purpose, we put it to have there a 404 to see how it looks in the end. Let's go fastly to the server architecture. We have an A/B deployment, or green-blue deployment, as you call it as well, where we have two servers which are completely the same from a hardware and software perspective. What we at kartenmacherei don't have to worry is like hot standbys and fallbacks and all this stuff. This is the data center providing to us, so we only handle A and B. And usual setup is all the requests goes to either box A or box B, but not to both at the same time. So let's stick with this setup. Let's stick with the idea that the box B is active and we want to deploy code on box A. So the build process looks like this, that we have first, we deploy the code to the machine. Then we run the collect and export as before. And as the next step, there is our smoke test coming into the game. And our smoke test then not testing directly against this box. But what we did there is we have a second URL or a dedicated URL set up on the main web server, on the main router at the top. So we can directly point to this box. So we really can test the whole chain and really have just this tiny little place for errors left. And that's a misconfiguration in the other web server configuration for the live system. So this is a tiny error which we still have. When everything is working, when everything was fine, we just switch to box A. Everything's fine. Box B turns off, and we can start the deployment there. Yeah, box A is active, sorted. The one more thing, when smoke tests fail, what happens? Next step is not started, so the box is like left alone in this state. And our next deployment is starting from scratch, like starting from deploying the code again. So we make sure that this machine gets deployed the next time in the same way until that finally works or we get it sorted. When the smoke tests fail, the good part is that a lot of developers get notified via email and HipChat. So anyone who's receiving this message first is supposed to look at this machine and see what's the problem and how we can achieve to make it work. because all of this is still a library and still has to be implemented like that, I was thinking for over a year now there should be a better way, there should be an easier way. And just as a short side note, I built this at the moment as a service, so you can directly attach to the system to a SmokeTest library, which is testing for you, so you don't even need to write a lot of code anymore. It just makes it, it's supposed to make it much easier for you as well. Prototype went live last week. But yeah, still a lot of things to improve there before we can start. That leads me already to the conclusion, like please do me and yourself the favor, write tests and write them thoroughly and write unit tests and really try to achieve the 100% code coverage, because that's the most important, that you have that you have code coverage in your system, because that helps you a lot. Another point is really smoke test your website for sure, is only activate the server if there is no smoke. So if there is smoke, please never activate this server, because the smoke is showing that there is something wrong, and this is nothing you want to have there. And the last but not least, I want to say thank you already. And yeah, I stay here for questions if there are. Good. Questions? Okay. No.
Thank you for the talk. So do you test all the pages on your website when you have this smoke test, or do you test the most important ones and only the ones that has 200, or do you try to do post tests?
Okay. We should have all pages because it's a manual list. It's not all the time up to date. But currently we are testing about 20 to 25,000 pages on each deployment. 6 minutes. Other questions? Okay, looks like everyone wants to go home. There are stickers down here if someone wants to have more stickers on your laptop. Besides that, I say again, thank you very much and have a good way home.